Okay, now the next question for electric field. 2-point charges Q1 and Q2. Okay, one is a negative charge, another one is a positive charge, are placed 0.1 meter apart. Okay, 0.1 meter apart. Calculate the total electric field at point A and point B. Okay, I want to find the total electric field at A and B. So let us do A first. Okay, and the question wants the the total electric field. So you see, this question doesn't ask about magnitude, and it doesn't specify magnitude and direction, isn't it? But we still have to give both. Okay, even he didn't specify he wants the direction. So you still need to give both the magnitude and also direction. These two you must give. If you don't give direction, you will lose mark. Okay, you will lose mark. And then got two answer. One is on A, and another one is on B. Okay, let us start with A. So on A, okay, let us draw the vector diagram first, because electric field is a vector. Okay, it's a vector. So on A, electric field depend only on point charge. Okay, who provide the electric field. Okay, it is the point charge that provide the electric field. So at point A, so electric field provided by Q1 is towards the negative charge. So E1 is towards the Q1. This is E1 towards Q1, because negative charge, the electric field is going going inward. Now how about Q2? Q2 is a positive point charge, so electric field is going outward. So at point A, electric field is going to the left also, because the electric field is going away from Q2. This is E2. Okay, so E1 is towards Q1, E2 is away from Q2. Okay, now let's calculate each electric field magnitude. Okay, to calculate magnitude of electric field, because this is a vector. Okay, a vector, for vector like electric field or force, the magnitude, we just want the positive value. We just want to maintain positive value. That's why our charge, we just ignore the negative sign. Okay, we just want to maintain positive value for vectors, for the magnitude of vectors. Okay, so let us substitute 9 exponent 9. And then the charge 1 is, what is charge 1? Charge 1 is negative 12 nanocoulomb. So the negative sign can be ignored. Okay, you just ignore the negative sign. Yeah, for vector, the charge, you just ignore the negative sign. Nano is negative 9. Yeah, nano is exponent negative 9. Okay, negative 9. Now, let us continue. So how far is it? What's the distance of Q1 to A? 4 cm only. So write 0.04 square, because change to meter. So what's the answer? I will get 67500 Newton per coulomb. That's it. Okay, that's for electric field due to Q1. Now how about Q2? Also the same thing. Q2, do the same way again. Q2 is a 12 nanocoulomb. So right there, 12 nano. Nano is negative 9. Okay. Then what's the distance? The distance is 6 cm away from Q2. So which is 0.06 square. Okay, 0.06 square. So it is 30,000 Newton per coulomb. Okay, 13,000 Newton per coulomb. That's the electric field due to Q2. Now, we know that these both of these electric field is to the left. So the direction, you need to put a positive negative sign because both of these to the left. So that means the direction is negative for both. Negative for both. Okay? Negative for both because direction to the left. So the E1 is a negative. Negative 67500, and then plus the E2 also to the left. To the left is negative, so put as a negative. Put as negative 30,000. That's it. Okay, negative means to the left. So in the end, you get the value negative 97500 Newton per coulomb. So what is the negative resultant means? Negative just show the direction. So that means the resultant now is in negative direction. Negative means to the left. Okay, the left. The resultant electric field sign is to the left. That's it. Okay, to the left. And negative sign here means to the left. Now, next, the question asks find the total electric field at point B also. Point B, the electric field for each one is different already because different distance. Yeah, this is 13 cm now. Okay, now let us first draw the electric field vector. Yeah, vector diagram. So, let us look. So for at position B, the electric field due to Q1 is towards the negative charge. So it is E1 over here. Okay, E1. And then how about Q2? Q2 is positive charge, means away from positive charge. Away from positive charge. So this is E2. E2. Okay. So next, okay, we got the direction already. Now we calculate each one of them. Okay, so electric field for Q1, so it's 9 exponent 9. What is Q1? Q1 is sometimes it's good if you write down the charge over here, write down information over here, so that easy for us to get the data. Better you write down here, Q1 is a negative 12 nanocoulomb. And then Q2 is 12 nanocoulomb. Better write down the information here, so easy for you to get the value. Now, to get the E1, so it has a negative charge, negative sign. So you just ignore the negative sign because we just want to maintain magnitude positive value. Okay, magnitude as positive value. So, okay, Q1 just because it's a negative test charge and negative point charge, we just ignore the negative sign. So it becomes a positive 12, negative 9. Okay, that's it. And then find the distance. Okay, I'm sorry again. Yeah, this is the one. Okay, so for this one, Q1, I ignore the negative sign. Yeah, even though it's a negative point charge, I ignore the negative sign because we want to maintain magnitude positive value. So how far is the point B to Q1? 13 cm. 13 cm. So it is 0.13 square. Okay, 0.13 square. So what's the value? I got 6390.5325 Newton per coulomb. Okay, and then for this one, for how about Q2? E2. You see, luckily Q2 has the same charge as Q1. Q2 same charge as Q1. What else? The distance also the same, 13 cm, 13 cm. It means R2 also equal to R1. So what it means? It means that this E2 is the same as E1 in terms of magnitude. This E1 is the same as E2 because they have the same charge, same distance. Yeah, same charge, 12, 12, and then same distance, 13, 13. Okay, so it is equal to E2. So now I got already the value for each electric field. So we need to find the resultant electric field. But this one involves the x and y components. X and y components, you need to resolve. You need to resolve the vector into x and y. X and y. Okay? X and y. So now, to resolve the vector, we need angles, isn't it? We need angles. So this angle we can find because we already have the sides. You see all the sides, we have 13 cm, 13 cm. How about this one? This one, 4 plus 6. 4 plus 6 is 10 cm. That means until the center here is 5 cm, 5 cm, 5 cm, isn't it? 5 cm, 5 cm. So this 13 cm. So the center one should be 12 cm, 5, 12, 13, 5, 12, 13. So now I can find the angle theta here, I can straight away use sin theta and cos theta. Okay. And then how about E2? E2 also got angle. This one also same angle. This one also theta. You see? And correspond to this one also. Yeah. Opposite and correspond to this angle. So you have theta with the y-axis. Yeah. For both, for E1 and E2, you have theta angle with y-axis. So now the direction. Direction have positive and negative sign. Direction have positive and negative sign. So be careful. Now for E1 and E2, so what's the direction? Let's look at E1. E1 is to the left and downward. To the left and downward. So that means to the left is negative, downward also negative. So we first of all we write the direction here. E1 is to the left and downward. So negative x, negative y. So let us put here negative sign first because it is to the left and downward. Okay. E1 is to the left and downward. So let's put the sign first. If not, we forget. That is dangerous. Okay. So never mind. I write again. So maintain as negative value first, yeah, because they are going to the left and downward. Now we want to resolve. Resolve. We need the angles. We need the angles. How do you do? What is the quickest way? Better you just find the, because what we need is sin theta and cos theta. Sin theta and cos theta. So you don't really need the theta. We just need the sin theta and cos theta to resolve the vector. So what you do is you just find the sin theta. Okay, find the sin theta. Sin theta is equal to opposite. Opposite is 5 over hypotenuse 13. 5 over 13. That's the sin theta. Okay, that's the sin theta. Now, how about the cos theta? Yeah, how about the cos theta? Cos theta is equal to adjacent over hypotenuse, which is 12 over 13. Okay. Do we really need to find the theta? Do we really need the time to find the theta itself? No need. We can straight away use the sin theta and cos theta here to straight away find our components for x and y. Okay? So that means, okay, so for E1, let's look at E1 first. E1, the x component is using sin theta. Because no angle. So it's the opposite side. So we use sin theta. So we put this as E1 sin theta. E1 sin theta. So E1 sin theta, you use the sin theta 5/13 to put into here 5/13. Okay, and then E1 is this one 6,300. Just put inside. So calculate and see what do you get. Calculate. After calculate, I got negative 2457 0.8971. Okay, that's it. Now about for y component. Y component, you have angle theta. So theta here. So adjacent. Use the adjacent. So that means this one use cos theta. Cos theta. So it is E1 cos theta going downward because negative. Yeah, going downward. E1 cos theta. So you just use all the available information here. So just now we already got the cos theta, isn't it? Cos theta 2/12/13. Straight away use in here. We already have the cos theta 12/13. So just use over here 12/13. E1 is what is E1? E1 is 6390. This one 6390. That's a E1. Multiply this E1 6390 multiply with the cos theta 12/13. Multiply the 12/13 and you will get the value negative 5898.9531. That's it. Okay. Okay. Now we solve the E1. Now how about E2? E2 is direction going to the left and upward. So x is negative, y is positive. So better you write down the sign first, negative and positive. X is negative, y is positive. X is negative, y is positive. So let's calculate. This is E2 sin theta. Okay, y sin theta, x component y sin theta. Because it is don't have angle, we just use sin theta. E2 sin theta. And some more, we know that E2 is the same as E1. E2 is the same as E1. Sin theta also the same. Sin theta is 5/13. So that means this one is the same value as this one. So let's substitute. So negative 2457.8971. Okay. All right. That's it. That's it. For x component. Now for y component. How about y component? The y component is going upward. Going upward is positive. This one, the angle theta is adjacent to y-axis. So the adjacent is the y component. So y component we use. So if we have angle, we have angle theta, we use cos theta. So y component is cos theta. But it's going upward. Upward is positive. So upward is positive. So this is E2 cos theta. E2 cos theta. E2 cos theta. So I get 5898.9531. So after that I can just cancel them off. I get 0. Right? I get 0. And then this one I get negative 4915.7942 Newton per coulomb. Okay. So what is the mean by this resultant? What we can see from here. The resultant electric field is negative 4915.79 Newton per coulomb. So means what? The negative sign here, it means electric field is to the left. The direction is to the left. That is the resultant electric field. Resultant electric field strength. magnitude and direction both. Okay, so that's all for this is the electric field strength at point B. Just write that as point B. Just now this one electric field strength at A, this one is at point B. Okay, so that's all for these questions. Let's move on to the next one. Thank you.